I want to welcome you to today's lecture. This is a Brukutu data set that we had and we used the last time, and we generated the summary statistics here. And we are going to continue to look at two things. One is correlation, the other is regression. This time is all hands-on practicals, hands-on practical. We do it in Excel, we do it in R. Now, for your assignment, you do everything in R Studio. So open it and work along with me, because at the end, I will take a picture screen of those that have worked along with me and I'll reward them, just so you know. So we're going to start first thing by doing a correlation analysis. You remember the definition of correlation is that correlation is the association between two variables. Now, the variables that are categorical, the location, the occupation, the religion, these variables, they are dummies. And because they are dummies, there is no need to find really their correlation. However, if you still want to find their correlation, you can. And by the way, in the slides, I've indicated why you shouldn't bother yourself finding their correlations. Okay. But if you still want to find their correlation, you have to use the Brukutu coded data. So this is a coded data where we have created dummy levels. For each dummy, we created levels. So again, when you check the videos, you see I've shown how you can use Excel to do this easily. So I created the location dummies from the location here. And then from the occupation categories, I created the occupation dummies for both occupation teaching and occupation trading. And for religion Christian and for religion Muslim, which means that out of the religions, Christians and Muslims were used, but Buddhist was not used. I just want to believe you've gone through this scenario at home for the past 1 week to know the data set you are dealing with. So there's always a reference category when you talk about the categorical variable. One of them is a reference category. And the reference category is the one that is not shown. So you can see that for religion, we have religion Christian, RC, religion Muslim, RM. There is one religion that was not brought here, which is religion Buddhist. That one, because it's not brought here, is a reference category. So it is a one we say any other one in reference to. So for example, when I say that Christians consume a lot of gin bitters, I am saying that in reference to Buddhists. So I'm actually saying that Christians consume more than Buddhists. So Buddhist becomes a reference category. Now, when you look at occupation, which one do you think is a reference category? Who can tell me? The occupation. When you look at occupation, who can tell me which occupation is a reference category? You do remember last time I told you that it is when you are responding to my questions, that is what slows me down. Yes, that slows me down. So because we have used this data multiple times, I expect that you know the data set. This is not the harder part. Okay. So you notice that that is the occupation fishing. And the location, the reference category is rural as well. Okay. So now let's generate the correlation matrix. Okay. The correlation matrix, you can generate it by clicking on Data tab at the top. On the far right, you choose Data Analysis. In the list, you select Correlation. Double-click Correlation, it opens Correlation. In the input range, you select only those variables that are numeric. So click Q, drag it to M, do Shift, Control Shift, and then arrow down, and that will select all of the numeric variables. Then you select labels in first row, which is here, and then select the new worksheet. Click on the white space. Label the worksheet we want to see the results. And let's call it COR for correlation. And you're done. Click OK. A new sheet will be created down here. So your eye should be looking down here. You see a new sheet added. And then you click OK. That new sheet has just been created and it is known as COR. So if you look at this new sheet, you will notice that it is in multiple places. So you want to click on Home tab, change the general, okay, and change the general to number. And that will put everything in two decimal places. Again, I have it in the video. I will encourage you to be doing these things. We're going to talk about this. Okay, there will be a correlation matrix that will be generated for you in the exam, and yours is to be able to interpret these coefficients. So I'm going to move from here, and I'll take you to a series of questions for you to address. You might want to write some of these questions down. Some of them are in your slides, but I'm being practical, so I'll create some questions right from here. So what are you seeing here? What is this? This is known as a correlation matrix. Okay. Now, before I continue to ask questions on this, we are going to do the same thing in R. Now, you can see that I only generated a correlation matrix for the numeric variables. So let's go to our R. Okay. And we are going to create a correlation matrix. Now, you have it in your slides. Let me just go to your slides so that you can appreciate already. To do the correlation matrix, and especially create a correlation matrix with p-values. I'll talk about the p-values very soon. To generate correlation matrix with p-values, you have to install this package known as Library H Miscellaneous. In fact, you have this in your slides, so you might want to copy and edit it. Okay. So copy, take that, and bring it somewhere here. So, Library H Miscellaneous. I have mine down here. Okay. Now, if you don't have Library H Miscellaneous, if you type it, you should have it. In order to know whether you have it, look on the far bottom right box here. Far bottom right box. Okay. If you check somewhere here, you will note that.
Prof.
Yeah.
Doc, it appears you are moving very fast, but I'm in my.
I told you from the onset that you answer my questions, and then you address. You ask questions. That is the only thing that stops me. Okay. So when I ask you questions, you have to raise your hand and talk. And I know some of you know the answer, so you got to stop and then answer my question. That's number one. Two, you have to ask me questions.
Yes, but I'm not able to access my R Studio.
Oh, you accessed it last time?
Yes, because what I have on the interface now, I'm on the console now, on the console interpage. But when I type and try to search, then it just
search for what? What are you searching for?
No, I'm actually making reference to the class that we actually made. If I tag like the R dot the clipboard dot delim read, it doesn't pop up.
It's not supposed to pop up. It is something you have typed long ago, last week. Or last week you didn't type it.
I typed it.
Yes, so it should be there. The moment you open it, it should be there, unless you didn't save it.
Because what I have on my console interface now, you see it tells me a bit about the version that I'm actually using, and then it tells you about the software, and then you see the greater than sign on that very interface.
But the interfaces are many. You see, we have the top part here, which is the command. Then we have the down part here, which is the console. So when you say interface, you have to be specific which one they are talking about.
Yeah, so I'm on the console, but mine doesn't appear like yours.
No, it's
Mine
not
is
supposed to appear like mine. It should never appear like mine. Because before this class, I've done a lot of other classes. So it will not appear like mine. So do not use mine to judge yours. You should just know what you are doing. So it depends on what do you want to do. Because I have not run anything so far.
Oh, okay.
I have not run anything so far to see anything. So whatever
Okay.
you are seeing down here is not what you should see.
Okay. Because you actually mentioned that we were going to be using the R for our assessment and our assignment and all of that. That's why I just wanted to be abreast with what you're actually doing.
I've not started.
Oh, okay.
I've only said that you should check here and type this, type in your command, wherever your command is. You see, mine is 220, command number 220. It doesn't mean that yours should be in 220 because I've typed a lot of things. So yours must be command number 6, number 7, number 8.
So Doc, that's the point I'm actually making. So me, I don't see the numbers.
You don't see what numbers in the command or in the console?
Yes, in the console.
No, you shouldn't see anything. Do you see anything in the console? No, you shouldn't see. You should see things rather in the command. So go to the top left, the command. That's where you should see numbers. That's where you should type. What have you typed in the command?
No, I've not typed in the I've not
So it
typed
means
in.
last week you did nothing. That's what it means. But you said you did something last week. Are you sure
Yes,
you did something?
yes,
Are you
yes,
sure
yes.
you did something last
Yes,
week?
I did. I did.
So why are you not seeing that? Because whatever you typed should be there. Are you sure you've opened R Studio or you've
Yes,
rather opened R?
yes, I have. I've opened our studio.
And you don't see anything you've typed?
No, 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 no.
So go to your document, your Word document here, and start typing everything in blue. Because we started last week from here. Copy this, paste it, edit, copy this, paste it, edit, copy it. You have the slide, don't you?
Yes, yes, yes.
So type, copy and paste them one by one until we get to the other bit. Because I did say last week that all of you should go and type all of these things before you come. Okay. So if you have typed these things, I even say copy and paste, copy and paste, copy and paste. So when we come here, you can even highlight all of them at the go like this, and then you can run all of them at the go. And you see the results populated like that. But if you didn't type or you didn't copy, you are going to struggle with what because I can't wait for you to type. That is not possible. That's why I gave you the note 1 month ago. I can't wait for you to type. So when you have the notes, it's nice that you go through the note a little bit. You know, like every day you go through it 30 minutes. That will help you. It's important you do that. It's important you do that after today. So that next week you don't struggle. It's important you type every code into your R. You just type. You don't even need to know what it means. Just type it before you come here. Type everything like this. Everything you see in blue. Type, copy, paste, everything, 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 copy, paste. That's how you do it. before you come. I've said that last week. I'm saying it again today. And next week, some might still have a challenge. All right. So the first thing you're going to do is to install the library site, library H miscellaneous, this one. Now to do that, all of you who are here should go to packages at the top, click on packages and choose install. Click on packages here and choose install down here. Click on install, a pop-up will show. You did this thing last week, but you did it for psych. Today you're doing it for HMIS, MISC. It actually, when you start typing, it will pop like it has popped here. And then you select it and click install. Do that, and you see something populating. When you click install, you see the thing moving around somewhere, some red dot. It will be moving around somewhere here for just some few minutes. After that, you'll be told that everything has been unpacked or uploaded. You see that actually in the console down here. Okay, let me show you something. So if you do H miscellaneous and you click install, you see it tells me that it has already been installed. So I don't need it, so I'll cancel it. Once you have installed, come and write this command, library, which again is in your note, library into bracket HMISC. Check the capitals and the small letters. Run this command. Run it. And when you run it, you see down here in blue, that shows that it has run. You see down there that it has run in blue. Okay. Now, the command that I'm actually working on, the command that we are actually working on is this command, rcore. Rcore, that's what we're actually dealing with, rcore. So after this library, you will now copy this from your note and paste it into your next R command. Now, I already have it. Okay. But if you don't have, that's what you do. So you do that just as I have here. So that is it. I'm highlighting this. It's R core. This is interesting. R core into bracket as dot matrix into bracket gin. Gin is the name of the data set. Now, for some of you, you may have to run your data set again. When I say run your data set again, what I mean is that you should have gin equal to read dot the name. You already have it up there. So you just go and run it. Click on it and run. Then you do double apostrophe, clipboard. So you should already have this up there. You run it, you highlight it, or you click anywhere inside it and do Control Enter to run, or do the run at the top. You see run at the top here, and then you click run. Yes, Gordon.
Yes, Doc. When I type in the gene equal to read dot delim into bracket the clipboard, the response is that in the read table, file is equal to file, header is equal to header, sep is equal to sep, code is equal to code. And it tells you the incomplete final line found by read table header on clipboard.
Okay, so what it simply means is that you have to recopy it from the Excel. So just go to your Excel. I'm sure you've opened your Excel.
Yes, I have.
So go to the Burkutu data set here. copy everything. So you can just click anywhere inside and do Control A. It will highlight everything. Control C, it will copy everything. Click anywhere inside. Do Control A, it will highlight everything. Control C, it will copy everything.
Prof, is the Brukutu data set on the on the on the out on the R studio?
It's in your Excel. If you check my screen, you see the Brukutu Excel, right? Or you don't have that Excel data?
No.
Oh, we used it last week. Doesn't mean you didn't use it last week. Is that your first time you're hearing of it?
No, I heard of it last week, so I thought it was because you actually mentioned that it was in the art studio.
No, I never mentioned it. I gave it to you, class. Class, do you have it? Can somebody confirm whether you have it?
Yes, we have it.
So, chief of staff, you don't contact your colleagues.
Oh, okay, Prof. Okay, no.
So go check the page. It's there.
Oh, okay.
It's been loaded multiple times. So somebody can just forward it on the page for him. That's why it's very nice that you communicate a lot to me on the page.
Obi, can you just resend it to the page here?
So you should copy this data set. Then that will work. You will not get that command. All right, let's move on. So you should have this data run. Now, in order to be sure whether this data is loaded, just highlight only the GIN. Highlight only the GIN and just run that alone. Once you do that, the whole data set will show down here, like mine is showing down here. You have the entire data set showing down here. So that means that your data has been loaded. So now you have your library H miscellaneous. You run that. You've already done that. You run it again. As you can see, that is down here as well. It is blue, meaning that it's been loaded. Now we are ready to generate the correlation matrix with p-value. But I want you to check something carefully here. This command, which I have highlighted, it has something called, after your R call, the R call is talking about the correlation matrix, okay, with p-values. Now, because we don't want, and this is all in your assignment, and some of them are in your exam, so it's very important you pay attention. Now, because we don't want the categorical variables, and in fact, if you don't remove the categorical variables, R will not work. It won't work. So this command which says minus which names gen, okay, percentage in, okay, and then we concatenate this one. That means you combine everything. We combine the location, the occupation, and the religion. So this command is saying that I want you to remove location, occupation, and religion from the data set before you run the result. So our result is not going to have the location, occupation, and religion because these are categories and we don't want to do correlations of them. And this latter number, which is 2, says that I want you to put everything in 2 decimal places. So once you run this command, it is going to generate the correlation matrix we saw in Excel. But in addition, it's going to give you the p-values. We shall talk about that pretty soon. So run that. Okay. If there are some mistakes, you'll be told. Okay, just as mine here, it is telling me that there are some mistakes. Okay. So if there are some mistakes, you don't worry, you will be informed. Okay. So for example, mine says that in call, not available in foreign function, blah, 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 blah. You have the following. In addition, in storage, double NAs, not attribute, cohesion, and all of that. Okay. So normally, Ordinarily, let me just go to your command you are using. Okay. Now you can see that this command I have here, that was the same command you had. Sometimes there's a slight typo. Okay? You have to double check to be sure. And slightest of typo not corrected will be penalized. That is how it works. You got to be precise, very precise. Okay. So I'm checking mine to be sure that everything is precise. I don't know why, but I'm sure some of you would have worked it. So check yours. The other ones you can use though, but let me just check. Okay, so there are two possibilities. One possibility is I have not attached the data set. Okay. So you can do something called attach. I just want to believe that this thing should work. Attach into bracket gen. But you have to detach when you're done so that there's never good. So I'm just typing the command for detach to bracket gen. So remember to detach before you exit. That's it. Now, what this attach is going to do is that it is going to force each variable to be recognized automatically. I want to believe I've even done this before. So let me see. Yeah. It's done it before. So let me detach. Let me detach again. And when you get some of these errors, you don't need to worry so much about it. It's part of the game. What you see on your screen, has any of you copied it? Have any of you typed it into your R Studio? All right. So let me quickly go to the R Studio. You should do this later, even if you can't do it now. So what you want to do is to run this command, R equals to C, because I've renamed this thing as C. Okay, I've renamed it. So R equal to capital C $R. I've sent this to you on your page. Then so that will generate the correlation matrix. Then P equals to C $P. That will also generate the P values. Then normally I will give you the whole correlation matrix, the lower level and the upper level, unlike the Excel. You see, the one in Excel is beautiful. The one in Excel is very beautiful. And I'm going to show you what I mean by it's very beautiful. So this is the Excel. And in the Excel, if you look at it here, you will see that the upper diagonal values, okay, where I've shaded, all the upper diagonal values are not there. So, because whatever is up there is the same thing that is in the lower diagonal values. When I say diagonal, I'm talking about everything below this line, everything below the 1, 1, 1, 1, 1. And please remember that the 1 is reflecting the correlation between Q and Q, between P and P. This is where you have to take your pen and write. Between C and C, the correlation coefficient is 1. Between M and M, the correlation coefficient is 1. Between Q and Q, the correlation coefficient is 1. It's perfect. It's perfect. It's perfect correlation. It's perfect correlation. Okay. Now, when we go to this R Studio, the result that we normally get is not beautiful like that. So I have to give a code that will make it much more beautiful. So this is a code. The code will generate a correlation. The next code will give you the p-values, and you will command that you don't want the upper part of the matrix of the box. The p-value 2, you don't want the upper part. Okay, so now I have run this command here, which is showing me the upper parts. Okay, and then this is the p-value. You can see it's down here. And this print will give me the correlation coefficient for the lower triangle or the lower part. That's what you see. So the upper part are not showing. And please remember that I am showing only the QPCM. Everything else is not being shown. Okay, QPCM. And then this next command here will give you the p-values. So the p-values will also be here. Now, I can give you these two. Let me just show you. I can give you these two I've highlighted, and I'll ask you 5 questions on that in the exams. And I'm going to address some of these 5 questions here, right? Okay.
Doc.
Yep.
Please, what you shared on the WhatsApp page, are we supposed to copy them one by one and run
You can
each?
do all at a go.
Do all at a go. Okay.
But you must have activated your library H miscellaneous. And then you must have run your gin before you start it.
Yeah, so I've run my gin, I've done the library.
And you are supposed to have this one.
Yes,
Where is
hit
this one.
the R
This command.
correlation.
Yes. I called it C. Okay, so if you like, I can put it in the page for you. I called it C. So that must be run first before you do the one I gave you in that order.
Okay, so after loading the data, I did the library. So I should just run what you just shared.
Yeah, the one that starts with capital C equals to R core.
Okay.
And then after that, you run the series of the other 6 that I gave. That will eventually bring you back to this correlation matrix together with the p-value. All right, let's try to now interpret what we have. The problem with the Excel one is that it only gives you the correlation matrix. It doesn't give you the p-values. But what do we mean by the p-values? If you could remember, we did this in ANOVA. The p-value is the error you make when you are undertaking any statistical analysis. The error you make, write it down, you forget the actual error. So let's look at the correlation matrix. Look down here. Okay. In here, we are showing the correlation between Q and Q, that is 1. Between P and P, that is 1. Between C and C, that is 1. Okay. And between M and M, that is also 1. Now, who can tell me the correlation coefficient between P and Q? Who can tell me the correlation coefficient between P and Q? Correct to 2 decimal place. Between P and Q, yes. Well, Bernard.
Negative 0.86.
Correct to 2 decimal place. What would it be? Because exam will always say correct to 2 decimal place.
It will be negative 0.87.
Correct. Now, what is the correlation coefficient between C and P? Between C and P.
Negative 0.74.
Between M and C.
Negative 0.1.
That's wrong. Between M
Negative
and C.
0.71.
Between M and Q.
.71.
Wrong. between M and
0.6,
Q.
0.61.
0.61. Guys, you should learn how to read correlation coefficients. You should learn deeply. When we were looking at the theory of correlation, we mentioned this. Okay. Now, that is not the main question I'll ask you, but you should know this to be able to answer the main question. The first thing is that if I ask you which pairs of variables, and you want to document some of these things, which pairs of variables are perfectly correlated? Which pairs are perfectly correlated? What you should notice that a correlation is said to be perfect if the coefficient is 1. Note it down. Okay. Perfect correlation are those that have got a coefficient of 1. So the first one is let me just start. Q. This is how you write it. Q and Q. Why? Because the correlation is equal to 1. So you put 1 in the bracket. Which other one are perfectly correlated? Which other ones?
P and P.
Mention that and then also put the coefficient in bracket. It's always important you put a coefficient in bracket. So which other ones are perfectly correlated? Abba, are you here? Abba, are you here? Abba. I know some of them are not here. That's why I'm calling them.
Yeah,
are you
Prof, please,
really
I'm here.
concentrating, Abba?
Yes, please.
Okay, so tell me the answer. Abba. Abba.
Prof.
Tell me the answer. Why do you turn on and then mute yourself again? I didn't say prof and then you immediately mute yourself. You're not concentrating. Yes, Belinda.
Sir, please, P and P1.
Okay. All right, let's move on. Now, I could ask you which variables are highly correlated with the dependent variable. Which variables are highly correlated with the dependent variable? Or which variables are highly correlated with the outcome? Which variable do you think, based on all this discussion, do you think is the outcome variable? Which variable? Which variable do you think is a dependent variable here?
Q.
It's Q. So if I say that which variable is the most highly correlated variable with the dependent variable, write it in as a pair. Write it as a pair. As a pair. Don't mention the variable. Write it as a pair. The way I've written the one on
P and Q
coefficient in bracket.
into brackets 0.87.
That is wrong. You see, you should have waited. You can tell me how to write it in a pair. Which is the most highly correlated variable with the dependent variable?
Is Q and C 0.72.
That is wrong. Which is the most highly correlated variable with the dependent variable?
Of P and Q, minus 0.87.
That's correct. So you're supposed to have it as P and Q. You see, what you should do now is to be writing, since you got it wrong earlier. Negative 0.87. The fact that it's negative doesn't make it wrong. It's still highly correlated in negative terms. This is what give it a 2 marks. And you will answer a number of these. Okay, so that's the first highly correlated variable with the dependent variable. Which is the second most highly correlated variable with a dependent variable? Second. In pairs.
I think C and P minus 0.74.
That's wrong. Which is the second most highly correlated variable with the dependent variable?
C and Q into bracket 0.72.
That is correct. So it is C and Q. Write it down. Write it down. You see, you don't know, somebody has mentioned that it's correct. What you do is you write it down.
But Prof, 0.74 is higher than 0.7.
It's not highly correlated with the dependent variable. Remember, the question is with the dependent variable.
Yeah, that's true.
Dependent variable. And already someone had confirmed that the dependent variable is Q. So the only column you're looking at is the first column, nothing else. So that's where Q is. Okay. Now, the question now is, let's take the first variable that is highly correlated with the dependent variable, which is P, and hence the correlation coefficient was P and Q into bracket negative 0.87. Okay, this was it. The question I'm asking you now is whether that is significant, whether the correlation is significant. And to check whether the correlation is significant, you come and check the p-value section, and this is the p-value section. And in the p-value section, since the variable itself was located somewhere as P and Q here, it was located here, the p-value you are going to select will also be in that same location. So you got to choose this particular p-value, okay, because that matches where the coefficient is. So look at the p-value. The p-value ends with E minus 13. What does that mean? The p-value ends with, 5.2493, blah, 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 E minus 13. What does that basically mean? It simply means that there are 13 zeros before the 5-2. Write it down. You will forget, I tell you. So if you don't write it down, you'll forget again. It simply means that there are 13 zeros before the 5-2. So that means that you have 0.0000012 zeros, then 5249. So basically, that number there is 0. That's what it means. Okay, 0, which means that the p-value is 0. And as you know, p-value is actual error. So it means that there is no error, because error is 0. There is no error as far as the coefficient between the price and the quantity is concerned. Therefore, that value, that p-value is below 5%, which means that the coefficient is significant. So the question I asked you was, is that coefficient, is the correlation significant? And the answer is yes, because the p-value, which is approximately 0, is less than 5%. And hence, the correlation is significant. Now, I want you to check the correlation coefficient between M and P. Between M and P, what is the value? Between M for income and P for price, what is the value of that coefficient?
So 6.99 to
See, you are
negative.
mistakenly checking where the P values are.
Oh, you asked me coefficient. Yes, yes. So it will be negative 0.5.
So that value, question is it significant? Is that value, is that coefficient between M and P, is it significant?
Yes, Prof. We can say that it is significant.
Why?
Because it's approximately 0 and is less than 6%.
6%. Did you say 6%? Did you say it's less than 6%?
6%.
No, we never use 6% as a benchmark.
Less than 5%.
Okay, what's the value itself? Which value are you talking about?
6
Which
point,
value are you saying is approximately 0?
6.99265 minus 0.4.
Okay, so that is exponent value, just so you know. I use E first of all, but that is actually the exponent value. Okay. So that is exponentiation value. Okay, so that is approximately 0. Okay. So it means that this number, which is negative 0.51, when you want to know whether it's significant, you come down and check the p-value. And the p-value is approximately 0 because there are 4 zeros before the 699. Therefore, it is less than 5%, and hence the coefficient above is significant. Now, there's so many questions here, I'd like to. When you look at the relationship between M and P, you notice that both of them are independent variables. Because the dependent variable here is only one. Write it down. Write it down. You see, some of them, your challenge is that you are not writing anything down. That's where you are lost. You are not writing anything down. So the more you keep not writing things down, your brain is not connected to your pen. Because there is an information symmetry between your brain and your hand. The moment you write something down, there is a 67 milliseconds of transfer of knowledge from the fingertips. And that raises your dopamine and oxytocin level. And therefore, you are able to pay attention more readily than you were originally paying attention because you have activated your fingerprint. This is so real. And so that is why you got to be used to writing and writing and writing. Some of you couldn't go through the computer work, but you must be writing. Okay. Now, when you look at that relationship between M and P, both of them are independent variables, and therefore we use variables that are highly correlated, but both are independent variables. We say they are multicollinear. We mentioned it the last time. In case you don't know, take note. Multicollinear variables are independent variables that are highly correlated with each other. Write it down. Okay. Multicollinear variables are those variables, those independent variables, highly correlated with each other. So when you look at this data set carefully, the top part, which variable will you say is the most highly multicollinear variable? When you look at this, which variable is the most highly multicollinear variable? Which pair? Christian.
C and P.
Always mention the value.
Negative 0.74.
If you write C and P in an exam without writing negative 0.74, everything is 0. I won't lie to you. So please take note. So that is it. That is the most highly multicollinear pair, because among the independent variables is the biggest. Now, question for you. Is that significant? This variable you just spoke about, is this significant? Is this significant? Who can tell me why or why not?
Prof, I think it is significant because it is approximately 0 and is less than 5%.
Perfect. Good, we are done. Let's go to the next thing for today. So I've just taken my time to walk you through all the necessary details you should know about correlation coefficient. Don't miss it. Don't miss it. This thing we've gone through are very, very important. Look at it against some of the questions you have, and you will appreciate it. Now let's go to regression. Regression. So I'll first do it in R, the Excel, before I come and do it in R. Now, Excel doesn't think. And so it will not be able to run these variables that are categorical variables unless we code them. So when we come to the to Excel here, I have coded these variables to be 0 or 1. In this case, they will make some sense to Excel. So for the regression, I'm going to use these ones. I'm going to use the coded one to run the regression. How do you do that? Once again, go to the top part, click on data. Then on the far right, choose data analysis. A pop-up will come, select regression. Select regression in the list. Double click on it. And you are now ready. In the regression, you'll be told to input your Y range. Input your Y range. That is the dependent variable. Write it down, write it down, write it down, write it down. Then you select the dependent variable. That dependent variable is our kill. So you come to column kill, you click and highlight and drag it all the way to the bottom. You are done. Click inside now the X range, input X range, the white space there. Click inside it. And for that, you are going to select all the other variables. So you select from P, click and hold and drag it, drag it, drag it, and drag it, and drag it to RM. Then drag it all the way down till you get to the end. Then you see that everything will be collected inside the input X range. You're done. Go to labels, tick labels, labels. Now, tick, you see the sheet there, which is known as the new worksheet. Click there and type reg. Reg to refer to a short form for regression. Reg. And click OK. Ideally, I could have done the simple regression first, but I just want to do the multiple regression at the go. Click OK. A new sheet will be created. The new sheet is going to be created down here somewhere. And this sheet is going to be called REG for reg. Let's click OK and see. So there you go. We have a new sheet that has been created, and this is known as reg. Now I can convert everything to 2 decimal places. So click at the home tab, then you see general in the middle here, general. Click on the little arrow near the general and select number. Everything will be in 2 decimal places. Job done. So now you can see that what you are having down here, everything here is the regression result. This is a lot of information there. And that's how you generate regression in Excel. There are important things you need to take note. But then you will have not use Excel. You use R. So we're going to do the same thing in R. But you should know Excel because Excel is on your fingertips. So that's why I've done this for you. So let's go and do the same thing in R. So go to your command center here. In fact, in your note, I've done for simple regression. Okay. And I've also done for multiple regression. Okay. But honestly, unless you can move fast with me. So let me go to, I want to see whether you can move fast. If you can move fast, great. If you can move fast. Because I didn't want to do the multiple regression. I didn't want to do the simple regression. I wanted to do the multiple regression. But on a second thought, I'm going to do the simple regression here. But that will require you to install a lot of packages. Because the simple regression I have is beautiful. But in order to enjoy the beauty, you need to note the following packages. Guys, anytime you see library in the code, that means that you have to install them for the first time. Okay. Anytime you see library, it means you have to install them. Now here, there are lots of things you don't need to install. But if you come here, you have install package. So that one, you've even done it, install package. So, and then you have library. That means you have installed. That's why you are loading. You have all of this in your note. So, we're going to do a simple regression, and we're going to regress blood pressure, quantity demanded on price. So look here, you have this command, you have it already. This command, that's what I'm going to run. It's going to give a scatter plot and then the regression line. So let's run that. You have it in yours. Okay, so copy and then follow me here. In fact, I have mine here. So this is a command, just run it. We'll show a beautiful graph on the right here. And you can see that on the y-axis, you have the quantity demanded, on the x-axis, you have the price. As you know, the higher the price, the lower the quantity demanded. Or the lower the quantity demanded, the higher the price. So you can see that as the price is increasing, from here going upward, what is happening to the quantity? Along the line, the quantity is falling. Okay. So there's a clear negative relationship between price and quantity demanded. Graphically speaking, this agrees with the law of demand. Okay. Now this is a simple regression. That's why we can draw. Okay. And then when you install these two packages, okay, and you have it in yours, when you install these two packages, GenGenP, MISC, and GenGenPlot2, okay, and then you library them. Library them means that you are loading them to use it for something. If you do this one, you can now draw another graph, which is much beautiful. And that graph is here. You can do that on your own later, but I'll just show you here, okay, because you have the code there. So when you library this thing, and then you show this graph, this is what you get. You see what you get here? There's something nice here, and this you will sometimes see in papers, journal papers. So this is a graph showing the relationship between price and quantity demanded. The price is a X, the quantity demanded is a Y. Okay, and you are seeing a scatter plot of the data set here. Okay, and you see the distribution of the data set around the fitted line. Now, what is the fitted line? The fitted line is the actual relationship. It is a desired quantity. Take note. You see, the actual quantity is the one you have in your data set. Let me just go to the Excel. So this is a data set. So when you look at this data set, the actual quantity is a kill. That's a kill. That's a kill. But this kill might not be the kill that you want. So if you look at shop 1, the quantity of bottles that they sell, that people demand from them is 160 every single year. That is shop 1. Shop 2, the quantity of bottles that people demand is 200. But the question is that, is this 160 and this 200, is that what they require? Is that what is desired? Is that what is predicted? Okay. That blue line you see here is a predicted line. And so some of the quantities are above it, as you can see in the dots. Some of the quantities are below it, as you see at the down. It creates an error. So some of the errors are positive, those above the blue line. Some of the errors are negative, those below the blue line. What a regression does is to minimize the error sum of squares and then come out with a beautiful result that you are seeing here. This result is known as the fitted line, which is a blue line, and then the regression equation, which is what you see down here. This is assuming that the independent variable is just 1, which in this case is price alone. So this is how you do it. Now you can run the simple regression here, which is what I've done down here, and you can see the result. So you can see that price alone is shown here. Watch the value. We call it estimate. Estimate. For the price, the estimate is -14. Now don't worry about what I'm saying here, because I'll come back and do it properly with the multiple regression. I'll repeat this. I just want to take price alone and tell you. So if you look at the price, it's -14.26. When you come down here in the graph, it is similar, negative 14.26, or round it to 2 decimal places is 3. So that is exactly what the graph is showing here. That is exactly what this one is showing here. We'll talk about the p-values, the stars, and all of those other things when we go to the multiple regression. But basically, what this simple regression is showing you is that first of all, there's a negative relationship between price and quantity, which simply means that looking at the 14, what it means is that if price should rise by 1 unit, quantity will fall by 14.26 units. You should learn how to interpret it. We'll do interpretation properly next time. Okay, so this is how this is supposed to be. If price rises, quantity falls. Okay, so this is just for the simple regression. But hey, there are other interesting things that you can do. There are other simple graphs you can do. Okay, that when you have time, you should check yourself with. Everything I've done is in your slides, by the way. Everything I've done is here. If you want to go through the slides, you see that as you go through the slides, you see. Now let's look at fitted and residual. One of the assumptions of the regression is that the error term must be 0. Write it down. Another name for the error term was the residuals, if you can remember, during the theories. The residual is that part you cannot explain. The independent variable are those parts you can explain. Now, I told you that there is a Q, which is the actual Q, and there is an expected Q, or the desired Q, or the predicted Q. Okay, that is called the fitted. So watch it. The fitted is the same as the predicted. So the fitted Q is a predicted Q. Okay, what is that? It is in this example, is a quantity demanded you actually want for each shop. You remember shop 1 had a quantity of 160. Shop 2 had a quantity of 200. As to whether those are the required, the desired, that's what you want, the fitted value will tell you. So let's go to the result and run this fitted. It's here. It's here. Once you run this fitted, you're going to get this result down here. Look at the result. You see, the beautiful thing about this result is that, you see, let's take the first one. You see the actual value was 160. But you can see that the fitted value is telling you that shop 1 desired 162. And if you can remember shop 2, what was the actual value for the shop 2? Quickly, who can tell me the actual value we saw in shop 2? Are you following? The actual value we saw in shop 2 is 200, and therefore the fitted is 204. So it shows that there is a deviation, a residual, an error of 4.9 thereabout. So for each variable, you have the fitted value and you have the actual value. You have the fitted value and you have the actual value. Okay. Now, therefore, you can find the residual or the error. So the next command, if you check your notes, the next command is a residual. I just ran it. And you can see that the residual for the first one is -2. The residual for the next one is -4.9. These are the residual. Some of the residuals will be positive. Some of them will be negative. Like this for shop 4 is 22, positive. Shop 5 is -15. Shop 6 is positive 6.4. So some of them will be positive, some of them will be negative. What the regression does is that it expects that the mean value of all of the errors, these errors you are seeing here, their mean will be 0. So I have a command here, and you have it also in yours, this command. When you run this command, you see that it should be 0. If it is not 0, your model is wrong. So let's run to find the mean of these errors. I called my data gene sample for sample regression. So let me run that and look down here. You see that the actual value is 16 zeros before the 4, -16 zeros before the 444. So that is approximately what? 0. So it means that the mean of the error is actually 0. That is good. That is good. The other things you can check later, but these are the main important things. So you go through these commands and you will find something very interesting. Okay. Now let's go to the substantive point for today. And that is the multiple regression. In fact, there are other things you can do. Okay. I will urge you to do it on your own because you have it in the slides. For example, when you install these two commands called RGL, these two packages, RGL and CAR, okay, and you'll be able to draw some more beautiful graphs. For example, you can generate a 3D graph. Okay, you can generate a 3D graph. This is a 3D graph. Oh, what is that? There are some beautiful 3D graphs you can generate. This one. So after this library, let's do one here. There you go. So you see this graph here? Now, some of your colleagues are not on the call. Tell them I'll take attendance. I just want to put on record. So this is a 3D graph. And in this 3D graph, you can move it and shift it. This is for quantity. So you can see quantity is here, complement price is here, and then price is there. So you can swingle this. Because it's a 3D, it's no longer a line, it's a surface. Okay, so you have something like a polyhedra, but you can make it a line. For example, if you want to show the relationship between price and quantity alone, watch it. Watch it. It's becoming a line. It's becoming a line. It's becoming a line. Now you have a line. You have a line. Okay. You have a beautiful line. But now you can move it and show the other part. And now it's no longer a line. It's a 3D surface. So there are beautiful ways you can show some of these things. Anything above the surface is positive. Anything below the surface is negative. Okay. So this is another beautiful graph that one can actually do. I just thought that you should have you can have a 4D graph, you can have a complete polyhedral as well. And then you can also show another graph. Let me show you. This is another graph. You can try it on your own. This one here. Again, it shows between quantity demanded, price, and then complement. So it's like a cuboid, okay, where you have the scatter plot inside it. All of these are different ways you can show. But life is if you show these things, it looks confusing. In fact, already some of your faces are clearly showing that you are confused. So that is why we always use a 2D graph. 2D. So when you go to 3D, people start getting confused. 4D. But life is multidimensional. Life is not 1D or 2D. For example, when you are standing and you are looking at me right now, your eye can see your left side, your front side, your corner side, your other right side. All of that is multidimensional looking. You see things multidimensionally. That's why your eye is powerful. And when we draw it, it looks a little bit different. Okay, so now let's go to multiple regression. The most important thing. Multiple regression. All the graphs are here. I've done the multiple regression for Excel for you already, so no problem. I'm just going to generate the multiple regression in the R. So follow me strictly. I beg you, follow me strictly. It will help you. All right. So let's start with the multiple regression. This is where I want to see those who follow me to the end. Everything we've done comes down to this. To run the multiple regression, we are just running this code. Don't use my page number to check your page number. Ideally, even if you have not loaded the data, this is a fresh look. You can load the data like this. You can look at the dimension if you want. And then you can run this command. This command will give you the multiple regression in R. I'm about to do that, and you should do the same. So this is a command. The first one is this one here. I ran that. You see, it is showing me the data set and then the dimension. And then now I can use the second command to run the multiple regression. This is the most important one. Let me run that here. Oh. Okay, so I need to load the data again in my case, because for some reason the data has been de-unloaded. So let's run this data and see the dimension. So the dimension tells you that you have 40 observations and 9 variables. By the way, please look here, this is a dimension. The DIM is telling you the dimension of the gene data set. And the dimension, the first one is the number of observations, that is a sample. And then the second one is the number of rows, or the number of columns. The first one is the number of rows. The second one is the number of columns. So there are 9 columns. 9 columns. Of course, the first one is another important one. 9 variables. Okay, 9 variables. All of them are here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. But in reality, the independent variables are more than that. Okay, now the next one is to show the regression. I called my regression model Gene Multi. I will encourage you to run that same regression. I'm about to ask which of you have been able to generate your regression. Gene Multi. So run your Gene Multi regression and show the results. So I'm going to run mine, and this is my result. You should run yours. I'm going to give you some 2 minutes to do that. Once you have run yours, let me know. Once you have run yours and you can see your results, let me know. Raise your hand if you've been able to do yours. If you're able to do yours, you run it and show me. I mean, raise your hand and let me be sure that you've been able to run it. So you got to tell yourself that you can do it and then do it powerfully. The mean squared error is good. Then the square root of the mean squared error, we call it RSF. What's it? R root mean squared error. That's it, root mean squared error. Okay. When you run this root mean squared error, that is also positive, which is very good. So these are ways you can just use to check the result. But I'm more interested in the residual, this one. Okay, the residual. And by the way, you have all of this, the residual. This is a residual, and the mean of the residual is supposed to be 0. You can see that this one is 0 down there. You have that. Check your Excel. Check your Excel. Everything I'm doing here is there. But this is the most important thing. I'm about to come and talk about this, which is in your Excel, in your slides. Everything I'm doing right now are these: the fitted, the residuals, the mean of the residuals, and all of that. So now let's go to the questions I will ask you in the exams and also in your assignment after this result has been obtained. So I'm going to show the result again. This is the complete regression result. This is the one I said I was waiting for some of you to show. Who has been able to run this so far? This is a one. So in an exam situation, I'll give you something like this, and I'll ask you 13 questions. I'm going to go through these 13 questions here. And then I'm going to go through these 13 questions here. Of course, not all of them today. So that when you meet them, you'll be able to appreciate them. So question number 1. And this is where you want to ask questions when you don't understand. Now, so far, in case you have been with us for the past 1 hour or so, and you did not even understand so far, this is where you have to open your mind, because what we're about to do now has nothing to do with anything. It has to do with a fresh mind. A fresh mind. A fresh mind. Because under the exam condition, you are not going to be running the software. I will run the software and I'll give you the result. And here I've run the software, and here I have the results here. And I'll ask you some questions based on these results you're seeing here. And those are the questions we're about to go through. So if you open your mind and follow through, you will be able to master what we're about to go through. So open your mind and follow what we're about to go through. Question number 1. This is your exam question. Specify the entire regression model based on your regression output using the same label as Python produced. Now, you guys did not use Python, use R. So as R produced. How will you show? This is a specification of the model. Now, in the beginning of this course, I told you that there is a difference between a specified model and an estimated regression equation. If you can remember, we used to say something like Q equals to beta 1 plus beta 2, x1 plus beta 3, x. Do you remember that thing? Class rep, do you remember?
Yes, Prof. I remember that you.
You remember very well, eh?
Yes, I'm trying to recollect, but I remember you mentioned it in class.
Yeah. So that is similar to what we're about to do. So when you look at this, how will you be able to specify the model? Well, the first thing you got to note is that you got to remember the dependent variable of this whole result. And you might not see the dependent variable here because the results will be given to you from this section. This is how you see that. So you will not actually see the dependent variable here. But when you go to the correlation matrix, the first variable that comes in the correlation matrix will be the dependent variable. Write it down somewhere. It will help you. The first variable that comes in the correlation matrix is the dependent variable. Okay. You will also see that dependent variable from the story that you'll be given. So there'll be a storyline. And the storyline will tell you about the dependent variable. Okay. So that is the one that should come first. Now, in this very story here we have, who can tell me what the dependent variable is? What is the dependent variable? Which variable is the dependent variable? Sam, how many minutes do we have?
We have 24 minutes.
Right. Now, the next important thing, next week is our last meeting, isn't it? Is next week our last meeting?
No, please, Prof. I think there will be one more meeting.